I'm Satvik Shah, and once again we are here with the new concept Shortcut Bridge MCQ from Gujarat Board to gujcet. So friends, in this new concept I will explain you the tough sums which are already asked in Gujarat Board, and then after I will give you my some prediction MCQ as per my 17 years of experience in this field. So friends, first of all we will discuss about Gujarat Board MCQs or gujcet MCQs which are already asked in Gujarat Board or in gujcet in 2024, 2025 as well as in 2026 exams, and then I will give you prediction MCQs. Okay friends, so listen to me carefully. I am starting with first question, chapter number 1 from Gujarat Board to gujcet MCQs. Question number 1 is given by f of x equals to 9 minus x raised to 9 whole raised to 1 by 9, and here friends you are going to evaluate value of f of x. So how you will find this value f of x? This is a composite function from f to f. So just how to find it, what was the process in chapter number 1? So we will break the function from O, it will become f of x. And friends, what is f of x? F of x is given by result number 1, 9 minus x raised to 9 raised to 1 by 9. Now we are going to evaluate f of 9 minus x raised to 9 raised to 1 by 9. So in this function, just replace x by whole of this value, 9 minus x raised to 9 raised to 1 by 9. So friends, 9 will remain as it is, raised to 9 will remain as it is, whole bracket will remain as it is, raised to 1 by 9 also as it is. Just replace x by the value 9 minus x raised to 9 raised to 1 by 9. So this 9 will be cancelled out. After simplification we will get friends 9 minus 9 plus x raised to 9 the whole power 1 by 9, and we know that powers always multiplied with each other, x raised to m that is x raised to m into n. So here you will get the answer x raised to 9 into 1 by 9, so x only. So this was your first question which was asked in March 2024 board exam, right? So friends, these questions are given in your example after 1.2 in Gujarat Board's exercise. So never ignore the sums of composite function as well as f inverse functions. It can be asked in board exams, and already it has been asked in board exam 2024. Now friends, we are moving toward question number 2. This question was asked recently in improvement exam of June 2026. So the question was a equal to x such that x cube equal to x will be any integer number, then find number of onto function from a to a. So first of all friends, solve this equation, find the possible values of x which belongs to z, and then after number of onto functions from a to a is given by some formula. So first of all we will solve this equation. X cube minus x equal to 0, x will be the common factor, then we will get x square minus 1. Here will be the factorization as per the formula a square minus b square. Its two factor will be a minus b, a plus b. So after solving the equation friends, we will get three values of x which belongs to z, -1, 0 and 1 friends. So we can say that friends, set A contains three elements, -1, 0 and 1. So if set A contains n element, then as per our shortcut formula of chapter 1, number of onto function from A to A is n factorial. So here number of onto function from A to A will be 3 factorial, which is given by 3 into 2 into 1 means 6, right? So friends, here students will mistake like this. X will be cancelled out, x square will be 1, so x will be only plus or minus 1. But because of this is third degree polynomial equation, you can't cancel out x from both sides directly until and unless given a condition that x not equal to 0. So the right way to solve this equation will be compare LHS minus RHS with 0, then solve the equation, and whichever the values of x may exist, just find it as per the given condition. So just keep in mind, friends. Now question number 3. This was asked in the last board exam, March 2026. Total number of equivalence relation, total number of maximum equivalence relation for set A equal to 1, 2 and 3. So here friends, we are going to find out value of number of maximum equivalence relation defined on set A equal to 1, 2 and 3. So your relation must be reflexive, must be symmetric, and also must be transitive. So first of all, equivalence relation containing the pair only 1, 2, that is given by 1, 1, 2, 2, 3, 3 and 1, 2 as well as 2, 1. So here friends, 1, 2 and 2, 1 will give you symmetric relation, but here just keep in mind we are getting two transitive pairs over here. 1, 2, 2, 1, then 1, 1 will be the transitive pair, and 2, 1, 1, 2 will be the sequence of AB and BC, then 2, 2 will be the transitive pair. So all the transitive pair which is possible should be there in your relation. So this will be your first relation, which is an equivalence relation. Now equivalence relation containing pair only 2, 3. So that is given by friends 1, 1, 2, 2, 3, 3, 2, 3 and 3, 2. Similarly, equivalence pair containing the pair only 1 and 3, that is given by 1, 1, 2, 2, 3, 3, 1, 3 and 3, 1. But just keep in mind here two transitive pairs are possible, 1, 3, 3, 1 then 1, 1 and 3, 1, 1, 3 then 3, 3 will also be one transitive pair. So just keep in mind. Now only reflexive relation is also an equivalence relation. I am repeating once again friends, only reflexive relation will always be an equivalence relation. So pair containing 1, 1, 2, 2, 3, 3 itself is not only a reflexive relation, but it will also be an equivalence relation. So this will be your fourth relation, which is an equivalence relation. Now fifth and last equivalence relation, friends. All the pairs which are present in a relation and will form an equivalence relation means friends, equivalence relation containing the pair 1, 2, 2, 3 and also 1, 3, that is given by your fifth equivalence relation, which is 1, 1, 2, 2, 3, 3, friends 1, 2, 2, 1, 2, 3, 3, 2 and 1, 3, 3, 1. This will be your fifth equivalence relation. So in this way friends, we will get equivalence relation containing only pair 1, 2, containing only pair 2, 3, equivalence relation containing only pair 1, 3, only reflexive relation, and equivalence relation containing all the pairs 1 2, 2 3 and 1 3. So in this way you will get maximum 5 equivalence relation on set A equal to 1, 2 and 3 friends. Question number 4 friends. Set A contains 5 elements, set B contains 7 elements, then total number of both 1 1 and onto function. So here friends we are going to evaluate both 1 1 as well as onto function, which is defined on some set A containing 5 elements and some set B containing 7 elements. Right friends? So here before we start the question, just keep in mind these conditions friends. First condition is, if set A contains m elements, set B contains n elements, then only 1 1 functions are possible, not onto function friends. And total number of 1 1 function is also given by some formula npm, which may exist just per the condition m less than or equal to n. So friends, whenever m less than or equal to n condition will be verified, then only total number of 1 1 function possible, and it is given by npm. Now friends, if m greater or equal to n is given to you, then total number of only onto functions are possible, not 1 1 function friends. And total number of onto function as per the given condition m greater or equal to n, that is given by sigma r equal to 1 to n minus 1 raised to n minus r into ncr into r raised to m. This formula will be useful to you, beneficial to you in gujcet exams friends. But this formula will be applicable only when condition m greater or equal to n is verified friends. The formula is also given by 2 raised to m minus n. This formula will also be applicable for number of only onto function based on m greater or equal to n. Now total number of both 1 1 as well as onto function are possible only when friends m equal to n. These two conditions will be intersect at the condition m equal to n. So you can say that whenever in both the sets, set A contains elements and set B contains some element, if both elements are same, then only both 1 1 as well as onto function exist, which is given by mpm or npn or m factorial or n factorial. So friends, both 1 1 and onto function must exist, but for m equal to n. Here we can clearly see that total number of elements in A is 5, total number of elements in B, that is 7. So m greater than n. So obviously second condition is verified but not first. So both 1 1 and onto function are not possible, and that is why answer of this question is 0. No 1 1 and onto function may exist. So this question was asked in 2026 March board exam. Right friends? So we will continue question number 5. So after completing this question 4, we are moving toward question number 5. So here will be friends question number 5. So friends, we are moving toward question number 5. A equal to 1 2 3. Then on this set A equal to 1 2 3, find total number of relations which containing pair 1 2 relation should be symmetric as well as transitive but not reflexive. So friends, we are going to find out only those relations which must contain pair 1 2. Relation must be symmetric transitive but not reflexive. So how many such relations are possible? So only one such relations are possible. Why? Suppose we are choosing 1-1 pair only and we are choosing 1-2. So for 1-2 pair to be symmetric, there must be 2-1 in a relation. So we can say that if 1-2 pair is present, then it must be symmetric only when 2-1 is also present in relation. But if 1-2 and 2-1 both present in relation, then friends, actually two transitive pairs are there which are possible. 1-2, 2-1. Then 1-1 will be the transitive pair, as well as friends 2-1 and 1-2. Then 2-2 will also be the transitive pair. So friends, just don't think like this: A1, B2, then for A equal to 1, B equal to 2, we will get 1-2 pair. For symmetric B2, C1, it will be 2-1, 2-1 will be the symmetric pair, but there will be two transitive pairs which are possible. From forward and reverse, it will be 1-2 belongs to relation, 2-1 belongs to relation, then 1-1 also belong to relation. And if you are starting from here, A equal to 2, B equal to 1, then 2-1 belongs to relation, 1-2 belongs to relation, then 2-2 must be a part of transitive pair. So friends, here we are getting only one relation which is not reflexive. Why this relation is not reflexive? Because all the reflexive pairs should be present in a relation. Here 3-3 pair is not present in a relation, friend. So that is why we can say that the relation is not fully reflexive, but it is symmetric and it is containing both the transitive pair 1-2, 2-1, then 1-1, and 2-1, 1-2, then 2-2. So this will be the only relation which is not reflexive but both symmetric and transitive, friends. So your answer will be only one relation. But this question can be asked like this: maximum number of relation which are symmetric and transitive but not reflexive. Then answer will be 3, friends. Pair containing only 1-2, then you will get only this relation number 1. Pair containing 2-3, then also you will get one relation 2-2, 3-3, 2-3 and 3-2. It will also be a relation which is symmetric and transitive but not reflexive. 1-1, 3-3 and 1-3, 3-1. Pair containing 1-3 only. So this will be the third relation which is not reflexive but symmetric and transitive. So if in a question, the question will be twisted like this: maximum number of relation, and here pair 1-2 is not mentioned, then your answer will be maximum number of 3 relations are possible, which is not reflexive but symmetric and transitive, friends. So this was the question number 5. This was asked in gujcet 2025 exam. Now friends, question number 6. This question was asked in improvement exam June 2026. R equal to xy such that y is divisible by x, x is an integer number, y is an integer number. Then what can you say about relation capital R, friends? First of all, we can say that x is always divisible by x, and friends, just keep in mind this hint: if y is divisible by x is given to you, just keep in mind y divided by x, y modulo x, right? So x is divisible by x, that is always true. 1 is divisible by 1, 2 is divisible by 2, 3 is divisible by 3. So you can say that R is reflexive pair. R is a reflexive relation. Here if we say 2, 4, which is belonging to relation means 4 is divisible by 2, then obviously 2 is not divisible by 4. So if 2 4 belongs to relation, then reverse pair 4 2 does not belong to relation. So relation is not symmetric, friends. And now we will check for transitive relation, friends. So here I have given one example. 32 is divisible by 16, 64 is divisible by 32, then 64 is also divisible by 16. So if you take some specific example, A16, B32, C64, then relation will automatically be transitive. So finally we are getting relation is reflexive, not symmetric but transitive. So your answer should be relation is reflexive and transitive but not symmetric, friends. Right? Now we are moving toward question number 7. This question was asked in June 2025 improvement exam. So friends, I am repeating once again, this question was asked in June 2025 improvement exam. F of x equal to 9 minus 2x minus x square, f from R to A is onto function on A, then find value of capital A. So friends, we are discussing this question and I am repeating once again, this question was asked in June 2025 improvement exam. So first of all, friends, if function is onto function, the range of a function and codomain of a function should be same. So students, you can say that whenever range equal to codomain, function will be onto function. So here we can say that capital A means codomain is nothing but range of a function means y. So just find range of f, it will be nothing but your capital A. So how to find range of a function, friends? It's a quadratic equation or 2-degree polynomial equation. So whenever you will see second-degree polynomial equation, just try to make it a perfect square by adjusting a last term. So last term is given by, friends, middle term square upon 4 into first term. So whenever you will get last term by using this formula, just put it over here, just add and subtract last term in a question, and then you can convert quadratic term into a perfect square term, either a plus b whole square or a minus b whole square. So students, we can see that here last term should be 1. So add 1, subtract 1. This will be a perfect square, x plus 1 whole square. This will be 9 plus 1, 10. So finally we are getting f of x in terms of perfect square, 10 minus x plus 1 whole square. And friends, we also know that for every x belongs to R, anything square should be greater or equal to 0. So we know the range of x plus 1 whole square. It is always greater or equal to 0. By multiplying minus 1 both the side, inequality will be changed. So minus of x plus 1 whole square, that is less than or equal to 0. Now add 10 both the sides to inequality. We will get, students, 10 minus x plus 1 whole square less than or equal to 10. So finally we are getting range of function which is from minus infinite to close interval 10. I am repeating once again, friends, range of a function is from open interval minus infinity to close interval 10. And we know that Range equal to codomain equal to capital A. So capital A is nothing but open interval minus infinite to close interval 10, or you can say that maximum value of capital A is 10. It can also be asked in the exams. What will be the maximum value of A? It will be 10, friends. But here right now our answer is from open interval minus infinite to close interval 10. Now we are moving toward question number 8. So see question number 8. So friends, question number 8. So we are moving toward question number 8. F from n to n, f of x equal to 7x minus 5. This question was asked in June 2026 improvement exam. So function is 1 1 or not, onto or not, just verify it. So you can verify by two ways. Friends, by definition, for every x1 x2 belongs to domain, f of x1 equal to f of x2 implies there should be x1 equal to x2. So we are starting with f of x1 equal to f of x2, means 7x1 minus 5, that should be equal to 7x2 minus 5. Minus 5 cancel out from both the side, 7 is cancelled out from both the side. So we can say that we are getting only x1 equal to x2. So function is 1 1, friends. Or else you can do the question like this, perform the question like this, just substitute value of x from domain. So replace x by 1, replace x by 2, replace x by 3 and verify. For different values of x, you are getting different values of function. For some element, value of function or mirror image should not be repeated. Then function is always 1 1, friends. So here f of 1 is 2, 1 is having mirror image 2, 2 is having mirror image 9, 3 is having mirror image 16. So different elements having different mirror image, function is 1 1. This is the second method. Now you can say that the general value of f of x is given by 2, 9, 16, 23. But if you put different values of x from domain, you will never get answer 3, 4, 5, 6, 7, 8, etc. You will never get the answer 10, 11, 12, 13, 14, 15, etc. So you can say that here range of function is not fully equal to codomain. So function is not onto, because for onto function each and every element in range, that should be equal to, friends, codomain. So here function is not onto. Right, friends? Now we are moving toward question number 9. So in question number 9, this was asked in March 2024 gujcet exam. F from n to n, f of x equal to x raised to 6. So again, just like question number 8, we are starting with the basic definition. For every x1 x2 belongs to domain, f of x1 equal to f of x2, then after simplification there must be x1 equal to x2, friends. F of x1 is x1 raised to 6, f of x2 is x2 raised to 6. By taking raised to 1 by 6 both the side, because of x1 x2 belongs to n, here is only x1 equal to x2. If I replace n by capital Z, here there will be plus or minus x2. Okay, so just keep in mind, if I replace n by z, the answer of question is not 1 1. Here right now function is 1 1. Or else you can do like this, replace x by 1, 2, 3, 4, just like previous example. So you will get f of 1 as 1 raised to 6, f of 2, 2 raised to 6, f of 3, 3 raised to 6. You are getting all the answer in terms of natural number raised to 6. So all the natural number like 2, 3, 4, 5, so many natural numbers are not included in this range, but codomain contains each and every element of natural set. So here also range is not fully equal to codomain, and therefore function is not onto. So now we are moving towards students question number 10. F from n to n, f of x equal to box of x, where box represents greatest integer function. In your textbook, the question is like this: f from R to R, f of x equal to box x. But in the previous exams, this question was asked like this, not from R to R, but from n to n, right? So friends, we know that box means greatest integer function 1.33, then its box will be 1, minus 1.33, then its box will be minus 2. But for integer numbers like 1, box of 1 is 1, box of 2 is 2, box of 3 is 3. So here our domain is not capital R, domain is capital N. So just replace x by 1, 2, 3, 4, box of 1, box of 2, box of 3 will always be 1, 2, 3, 4, all the natural numbers. So you can say that for different elements, function has different values, or you can say that every different element having different mirror image. So function is 1 to 1. Now friends, if we substitute the values like this, f of 1, f of 2, f of 3, f of 4 and so on, we will get range of function or y as an answer of 1, 2, 3, 4 till infinity. So range, codomain, both are equal. Function is onto function. But keep in mind, from R to R, range will be capital Z. So at that time, the function will not be onto function as per your textbook. But here our answer is both 1, 1 and onto function for f of x equal to box x varies from n to n. So friends, here will be some tough or some important MCQs which were already asked in your board or gujcet exam. Now I am going to give you my prediction MCQs as per my experience of this field from question number 11 to question number 21. So these are important or tough or my prediction MCQs for your next year board or gujcet exam. So now we will continue question number 11. So just be here friends. Now we are moving toward question number 11. So friends, question number 11, we are moving toward question number 11. F of x is given to you, function is onto from R2 close interval minus 2 to open interval infinity. Then what can you say about unknown value b? As per our previous discussion friends, if anything is there in terms of quadratic equation or in terms of second degree polynomial equation, try to make it a perfect square. So here friends, we have taken three terms together: x square minus 12ax plus 36a square. This will become a perfect square just like a minus b whole square. So this will be x minus 6a whole square friends, plus the remaining term will be friends 34 plus 12b. We know that for every x belongs to R, anything square is greater or equal to 0. So just add 34 plus 12b both the side to equation friends. So we will get range of function which is given by 34 plus 12b, and because of friends function is onto function, range should be equal to codomain. So 34 plus 12b must be equal to minus 2 if function is onto friends. So because of function is onto, now we can compare 34 plus 12b with the part minus 2. Now subject to b, After simplification, you will get value of b as -3 friends, right? So this MCQ is also very important for next board or gujcet exams, friends. Now A contains 4 elements 1, 2, 3, 4 and B contains 2 elements 1 and 2. Say number of elements in A equal to M equals to 4, number of elements in B equals to N equal to 2. Find total number of onto function from A to B. First verify condition, friends. Here M greater or equal to N, therefore total number of onto function are possible. Because of onto functions are possible, onto functions are given by two of the formula 2 raised to m minus n or sigma r equal to 1 to n minus 1 raised to n minus r into ncr into r raised to m, friends. By first formula, your answer should be 2 raised to 4 minus 2 because m is 4, n is 2. And by second formula, your answer should be just replace m by 4, n by 2, remove sigma. First replace r by 1, then replace r by 2, then add both the terms. You will get your final answer 14 by both the formulas. You can apply any one of the formula at a time, friends. Right? Now, question number 13. It is also the most important MCQ that can be asked in gujcet. F of x is given by 9 minus x p x minus 5. Then what will be the range of function for this f of x? First of all, we have to move toward chapter number 6 of 11, permutation and combination. NPR is defined, total number of things is n, total number of places are r, then NPR is given by n factorial upon n minus r the whole factorial, friends. This condition is valid only when number of things belongs to n, number of places belongs to whole number, and number of things should be greater or equal to number of places. So whenever you are taking intersection of all of these three conditions, you will get domain of f or you will get values of x for which f of x exists. Then find all the possible values of x and put it into the f of x. You will get the required range of function. But before you are finding range, define domain. And what is domain? Intersection of condition 1 and condition 2 and condition 3. So intersection of all three conditions is 5, 6 and 7. So domain of f or values of x for which f of x may exist, that is 5, 6 and 7. So range of f is given by f of 5, f of 6 and f of 7. Just in this formula, first replace x by 5, then replace x by 6 and then replace x by 7. You will get 4p0, 3p1 and 2p2, means your range of function will be 1, 2 and 3. So this will be the students' question number 13. It is also the most important question. Now question number 14. Just like question number 12, whenever total number of onto function may exist, m should be greater or equal to n. For one function, m should be less than or equal to n. Here m less than or equal to n is possible, therefore total number of only one function is possible by using the formula npm. Now friends, n is 10, m is 5, so your answer should be 10p5, which is 30240, friends. So these were the starting or beginning of my prediction MCQs from question 11 to question 14. Now I am moving toward question number 15. So here will be the question number 15. Okay friends, so we are continuing now question number 15. F from r plus to close interval minus 5 to open interval infinity f of x is given by 9x square plus 6x minus 5, then what will be f inverse 3? We know that, friends, if f of x equal to y, range equal to codomain, then x is given by f inverse y. So f inverse y is nothing but inverse function of f in terms of variable y. For f inverse y, first you have to find out value of small x. So how to find small x, friends? Compare f of x with y. Because of this is a quadratic term, try to make it a perfect square. Last term is missing. Add last term both the sides. So LHS will be the perfect square. RHS will be y plus 6. By taking square root both the side, we will get plus or minus root y plus 6. That should be equal to 3x plus 1, friends. So now, subject to x, you will get the value minus 1 plus or minus root y plus 6 by 3, but minus 1 will be negative, minus of root y minus 6, that will also be negative. So negative plus negative will never be positive, will never belong in domain. So minus 1 minus root y minus 6 by 3, this case is rejected. So f inverse y means x, that is equals to, friend, root y plus 6 minus 1 by 3. So students, here replace y by 3 both the side, you will get the answer of f inverse 3, which is given by square root 9 minus 1 whole by 3, that is 2 by 3. So f inverse 3 will be, friends, 2 by 3. Now, friends, f of x equal to x square, question number 16. G of x equal to 10x, h of x equal to log x. What will be the answer of HOGO f of root of pi by 4? Because of this is a composite function, say h of g of f of square root pi by 4. Now we know that, friends, f of x equal to x square. So students, f of root pi by 4 will be only pi by 4. G of pi by 4 will be 10 pi by 4, that is 1. So finally you require the answer of h of 1. H of 1 means log of 1, that is 0. So this will be your final answer, log of 1 means 0. Now we are moving toward question number 17, friends. F of x equal to box of x, g of x equal to modulus x. Find FOG of minus 5 by 3 minus GOF of minus 5 by 3. Here box represents greatest integer function and this is nothing but modulus function. So now we are simplifying the question. F of g of minus 5 by 3 minus g of f of minus 5 by 3. Now g of x is, students, modulus x. So g of minus 5 by 3 will be modulus of minus 5 by 3 and g of minus 5 by 3 in box. Minus 1 point something in box, its box will be minus 2. Now you are getting f of 5 by 3 minus g of minus 2. 5 by 3 in greatest integer function. 1 point something, its box will be 1 and minus 2 in modulus, that is plus 2. So your answer will be plus 1 minus 2, that is minus 1, friends. Now similar type of question, question number 18. F of x and g of x is given to you. FOG of x equal to GOF of x. What will be the value of k? So f of 2x minus k, that is equals to, students, g of 3x minus 5. Now f of x is 3x minus 5. So just in this condition, replace every x by 2x minus k. So here friends, f of, so question number 18, friends, f of 2x minus k. So in f of x, just replace x by 2x minus k. So f of 2x minus k, that will be 3 into 2x minus k minus 5. And g of x is given to you, friends. So just in g of x, replace every x by 3x minus 5. By simplifying, 6x will be cancelled out. Subject to k, the value of k will be 5 by 2, friends. By mistake, I have written over here 2x minus 5. So I am just correcting it by replacing 2x minus k. Now friends, we are starting from question number 19. So we are moving toward question number 19. So friends, we are moving toward question number 19. Find domain of f for the function tan inverse of square root 4 into x square plus x plus 1. First simplify x square plus x plus 1. So because of this is a quadratic term or second degree polynomial equation, first adjust last term, which should be 1 by 4. So add 1 by 4, subtract 1 by 4, you will get x plus 1 by 2 the whole square plus 3 by 4. And students, as per our previous discussion, anything square is greater or equal to 0. By adding 3 by 4 both the side, we will get the range of anything square plus 3 by 4, which is greater or equal to 3 by 4. Then multiply 4 both the side to inequality, we will get under root of 4 into x plus half whole square plus 3 by 4, that is greater or equal to 3 in square root, so square root 3. Then apply tan inverse both the side to inequality, we will get the answer greater or equal to tan inverse root 3 or greater or equal to pi by 3. But because of range of tan inverse x is open interval minus pi by 2, 2 pi by 2. So obviously value is greater or equal to pi by 3, but it should be less than pi by 2. So we can say that from 2 and 3, domain of f will be greater or equal to pi by 3, but less than pi by 2. So close interval pi by 3 to open interval pi by 2, that will be your final answer, students. Now question number 20. Just like our previous questions of gujcet exams, I have just changed this question by maximum number of relation on set 1 to 3, which is not reflexive but symmetric and transitive. So here answer will be maximum 3 relation which are not reflexive but symmetric and transitive, friends. First relation is relation containing only pair 1 2, that is 1 1 2 2, 1 2 and 2 1. Second relation which is not reflexive but transitive and symmetric 2 2 3 3 and 2 2 3 3 2, which is containing the pair only 2 3. Now third relation which is not reflexive but symmetric and transitive 1 1 3 3, 1 3 and 3 1. Right, friends? So we can say that total 3 relations are possible containing pair 1 2, containing pair 2 3 and containing pair 1 3, which are not reflexive but still symmetric and transitive. Now last question from my prediction MCQs, friends. F of x equal to 5 raised to x plus 5 raised to modulus x. F from R to R. Then function will be which kind of function? First, just replace x by minus 1 both the side. We will get the answer 1 by 5 plus 5 means 26 by 5. If I replace x by some log arithmetic term, f of log 13 by 5 base 5. So 5 raised to log 13 by 5 base 5, as per the property it will become 13 by 5, and this term will also be 13 by 5 by property. So again you are getting 26 by 5 as an answer of f of log 13 by 5 base 5. So f of minus 1 is 26 by 5. Also f of log 13 by 5 base 5, that is also 26 by 5. So these are two different elements having one mirror image 26 by 5. So it is many one function and not one function. Now as we know that any exponent is always greater than 0 or any exponent belongs to R plus. So 5 raised to x and 5 raised to modulus x both are positive real numbers. If we add them, then also range of function will be r plus, that is not equal to fully codomain r. So function is not onto. So we can say that function is not 1 1 and function is not onto. I will also provide you some practice MCQs in the next prediction MCQ sheet. So just follow description portion for the next video or see in the description portion for the practice MCQs of chapter number 1.